In this video, I'm going to do some more advanced limit laws. In the last video, we did the basic ones, so now I'm going to try to do it with some different kinds of functions. So for instance, I'm going to start off with f of x goes to L sub 1 as x goes to n, and I'm also going to do g of x goes to L sub 2 as x goes to n. Notice they're going to the same number, the same x value, and they're having two different y values as their answers. So for instance, I'm going to start off with this first one, which is scalar multiplication, which is basically if you multiply a function by some number, and I'm just going to call the number b, what's going to happen to the limit is you're just going to multiply it by the number b. So for example, just very quickly, if I had the limit as x approaches 1 of 3 times x. Well, in the last video we talked about if I'm just trying to find the limit as x approaches 1 of x, all I have to do is plug it in. Well, so that means it's going to be 3 times 1, which is just 3. Now, that should make more sense when we're doing other lines. Now, I'm going to talk about a sum real fast. So if we're doing a sum, we're going to have the limit as x approaches n of f of x plus g of x. What can happen is we add the two limits together, okay? So, for example, and I'm just going to do a real quick one, if I take the limit as x approaches n of 3x plus 5, notice that's that same kind of problem I had from the last one, and I'm going to pick, let's do 2 here. I'm going to actually just do the same kind of idea. I'm going to do the 3 times the 2, and the limit of a constant, no matter what this number is, the limit as x approaches 2 of 5 is just 5. So I'm going to do 3 times 2 plus 5, which makes 11. Okay? So notice I'm slowly building up more and more difficult functions, but it's still working out nicely. Now the same thing is going to happen with the distance. The only thing I'm going to do is instead of this being a plus, it's going to be a minus. Same thing's going to happen over here. For multiplication, same kind of idea. I'm going to write this down. So if I have two functions that are being multiplied together, for instance, f of x times g of x, I could just multiply their limits together. Now, you're probably wondering, well, when would this come up? Well, that's a good question. Very simply, x approaches, I'll say 0 of the functions x plus 1 times x plus 3. So all I would have to do is find the two limits separately and then multiply them together. Well, the limit as x plus 1 is 0 plus 1, because again, you can just plug in for the x here. Limit as a constant, it's just that number. I can multiply that by 0 plus 3. Again, linear constant. So 0 plus 1 is 1. 0 plus 3 is 3. All I got to do is multiply them together. I get 3. So that's the thing, is when I'm doing these, I can actually perform the operation to the limits and it still works. Now I'm going to go ahead and erase some of this so I can work on the division one, okay? Now this division one down here at the bottom, I know it's kind of hard to see, but it's down there. See it? Okay? It's going to work the same way, but I have one restriction. So I'm going to do the division. Limit as x approaches n of f of x divided by g of x is going to be L sub 1 divided by L sub 2, as long as L sub 2 is not 0. Because remember one thing, you cannot divide by 0. So again, if I had that situation, and I'm just going to, again, give you a very brief example. If I had the limit as x approaches 0 of x plus 1 divided by x plus 3, it's okay to just divide those two limits. So do the top one. X plus 1, well, limit of x approaches 0 of x is 0. Limit as x approaches 0 of 1 is 1. Same kind of thing happens on the bottom. 0 plus 3. We get 1 divided by 3, which is just 1/3. But let me repeat again, one more time, just to make sure I get my point across. The bottom limit, the thing on the bottom, cannot go to 0. Okay? That's an important one. The other one we've already talked about were power and roots. I'm just going to very briefly gloss over this. The limit as x approaches some number of any function raised to a power is just going to be that limit to the power. And the same kind of thing happens with the roots. So for instance, the limit as x approaches n of a root of f of x is just going to be that root of the limit. So again, you're going to kind of ask me, when would these be useful? When would these be helpful? I'll do a real quick example of a power. The limit as x approaches, I'll pick 3 this time, of x minus 2 cubed. Well, again, all I got to do, find the limit of the stuff on the inside, then cube it. So 3 minus 2 cubed. 3 minus 2 is 1. Cubed makes 1. So my answer there is 1. I'm kind of running out of screen over there. So I'm going to turn my computer just so you guys can see it. Roots. Again, same kind of issue. If I have a root, and I'm going to pick, I guess I'll pick 3 again. And I'll do the root of x plus 1, and I'm going to do the square root. Again, all you have to do, find the limit of the stuff on the inside, and then perform the root. So 3 plus 1 makes 4. Square root of 4 is 2. Again, just a reminder though, in this situation, if your index, if your the number outside is an even number like 2, 4, 6, or 8, your f of x, the limit cannot be negative. So I couldn't have had negative 4 in here because that doesn't come out as a real number. So again, just keep in mind some of the same rules with algebra stuff applies here because that's really what we're doing. We're doing algebra with limits.